just like there were differentiation rules, there are basic integration rules that, while you could have a table, are generally accepted as things that you're probably going to want to memorize because they come up so often that it's easier to just have it in your head than it is to try to look it up in a table. Let's start. The first one is that the integral of 0 is just an arbitrary constant. And the way that we can validate all of these, by the way, is to take the derivative. The derivative of a constant is 0. Therefore, the antiderivative of 0 is a constant. Over here, the derivative of k times x is just k. So the integral of k dx is kx plus c. The integral of a constant times a function is the constant times the integral. And that makes a lot of sense because remember that with derivatives we can factor out a constant. What we find is with integrals we can also factor out a constant, which is very convenient. If we take the integral of two functions added together, we can take their integrals separately and then add the outputs of that. Now, I want to be a little bit careful. That's only valid if these are what are known as integrable functions. Now, we haven't talked about what it means for a function to not be integrable, but this really only holds in the case where f and g are integrable separately. So I just feel the need to kind of add that asterisk there. So if they're added together, you just add their integrals together. If they're subtracted, you take their integrals and subtract. So you really can split the integral up is the big piece here. Now we've already done the power rule for polynomials. You add 1 to the power, divide by the new power, and then add a constant. Notice that that's the exact opposite. In the differentiation case, you bring down the power and multiply. But I do want to point out that this is not valid if n is -1. So like the integral of 1 over x does not follow this pattern. If you think about it, it makes sense because if you plug in -1 here, you get x to the 0 over 0. And that's a pretty nonsensical term. What we're going to find as we go on is there is an answer in the case where n is -1. It just does not follow this formula. It's an extremely special case. Now, because it's not just for integer values, as long as n's not -1, it works for everything. It even works in the case where n is 0, because x to the 0 is just a number, and that's just a number. So it's just a number times x, or in this particular case, x to the 0 is 1, so it's 1, x to the power, so it's x to the 1 over 1, so it's just x, which is a special case of this. Just kind of an interesting tidbit. Anyway, this is the hard one. This is the one everybody hates, the trig one. The derivative of sine was cosine, so the antiderivative of cosine is positive sine. This is where everybody gets screwed up because they start forgetting, okay, which one has the negative and blah, blah, blah. And it was hard enough to remember when it was just derivatives. Now with antiderivatives, it's the exact opposite. The antiderivative of cosine doesn't add a negative. The antiderivative of sine does add a negative, which is exactly the opposite of what it was with differentiation, which makes sense because it's the opposite direction. So sine derives to cosine, cosine derives to negative sine, so you need that negative to balance it out. Tangent derives to secant squared, so secant squared antiderives to tangent of x. Secant derives to secant x tangent x, so secant x tangent x antiderives to secant of x. And similarly for cosecant squared x and cosecant cotangent x, you have negative cotangent x and negative cosecant x, respectively. And of course, we always have our arbitrary constant. I didn't say that for each one, but do not forget your arbitrary constant. Say it with me. I know you're wherever you are at home. I want you to say it out loud. If you don't say it out loud, you do not mean it. Always add your arbitrary constant. Do not forget your arbitrary constant. If there is one thing that students are horrible about, it's forgetting this. This is a good way to lose points on an examination because you forgot about an arbitrary constant. Something you didn't even have to compute. Do not forget your arbitrary constant. Okay? Hey, alright. You feel better now that you've yelled it and screamed at the screen or screamed at me, whatever. Anyway, we're going to do some examples and we're going to put these to use.